Next, question number 33. In cosmic rays, 0.15 protons per centimeter square per second are entering the Earth's atmosphere. If the radius of the Earth is 6,400 kilometers, the current received by the Earth in the form of cosmic rays is nearly. The current basic definition आपल्याला माहितीच आहे. Let small q is equal to number of protons entering or received on unit area of Earth surface per second. Capital Q is equal to total number of protons received per second on Earth surface. Therefore, Q is equal to total number of protons received per second on Earth's surface of area capital A. So Q is equal to small q multiplied by A is equal to small q multiplied by 4 pi r square. This is equation 1. R is equal to radius of Earth. Radius of the Earth is equal to 6,400 kilometer. That is equal to 6.4 into 10 raised to 6 meter. Is equal to 6.4 into 10 raised to 8 centimeter. T is equal to 1 second. Times small t is equal to 1 second. Therefore, I is equal to current received on Earth by cosmic rays. It is also called as a cosmic ray current. So I is equal to Q by T is equal to small q into 4 pi capital R square upon T. So this Q is given in centimeter square, where Q is equal to 0.15 protons per centimeter square per second. म्हणून हा सेंटीमीटर स्क्वेअरमध्ये, म्हणून एरिया पण सेंटीमीटर स्क्वेअरमध्ये आपल्याला कॅल्क्युलेट करायचं आहे. म्हणून मी रेडियसची व्हॅल्यू सेंटीमीटरमध्ये कन्वर्ट करून घेतली. सो आय इज इक्वल टू क्यू इज इक्वल टू 0.15 multiplied by 4 multiplied by 3.14 multiplied by 6.4 into 10 raised to 8 bracket square upon 1/6. So 0.15 into 4, so that is equal to 0.6 multiplied by 3.14 multiplied by 6.4 multiplied by Q is equal to small q into E, proton, charge of proton. E is equal to charge of proton. The प्रोटॉनचा चार्ज आपल्याला दिलेला आहे 1.6. इलेक्ट्रॉनचा चार्ज असतो 1.6 into 10 raised to minus 19. So simplify. This is 1.6 and this is 0.6. So this is equal to 0.96 multiplied by 3.14 multiplied by 6.4 the square into 10 raised to minus 3 ampere. So square of 6.4. डायरेक्ट लॉग टेबलमध्ये स्क्वेअरचं टेबल दिलेलं आहे, त्याच्यात आपण 6.4 40.96 40.96. So approximately this is 1 and this is nearly 41 multiplied by 3 like this, 41 multiplied by, so it is 1.2 something. So 1.2 common दिलेला आहे. So this is 41 multiplied, so this is nearly 120 into 10 raised to minus 3, so that is equal to 0.12 ampere. So current I is equal to 0.12 ampere. So A choice is correct. A is correct. So this value is given in centimeter square. Remember this. And therefore you have to convert this radius in meter to centimeter, kilometer, meter and centimeter. So when we calculate area, this area should be in centimeter square because this is given for per centimeter square. एक तर याचे मीटर स्क्वेअर करा, नाही तर याचे सेंटीमीटर स्क्वेअर करा, काहीतरी एक करावं लागेल. So unit conversions are important in this case. So in this case we have to find the current received on the earth surface in the form of cosmic rays. So general definition is Q by T. So Q is a total charge received during the cosmic rays and it is equal to Q multiplied by 4 pi r square into E. E is a charge of the proton. This Q is a protons received per second per centimeter square. So this is in per centimeter square. Therefore, radius of the earth is converted into centimeter like this. So unit conversions are important in this case. Next, question number 34. A conductor with rectangular cross section has the dimensions A 2 times A multiplied by 2A multiplied by 4 times as shown in the figure. The resistance across AB is R1, across CD is R2 and across EF is R3. Then we have to compare R1, R2, R3. The problem only figure more easy. So I will try for that. So the given conductor is like this. So it's this side is A, height is 2A and length is 4A. A, 2A, 4A. So dimensions are different and they are shown as shown in the figure. So this AB line is x-axis. AB is equal to x-axis. CD is equal to y-axis. And EF is equal to z-axis. Resistance. First I will write down general formula. Resistance R is equal to rho into L upon E. Rho is equal to specific resistance L is equal to length, A is equal to area of cross section, area of cross section. Case number 1. R1 is equal to resistance along the path AB. So R1 is equal to RAB is equal to RXX is equal to rho into LX upon now area of cross section. Area of cross section will be this A multiplied by 2A. So rho into length is 4A. This is LX. LX is equal to 4 times A. Ly is equal to 2 times E, and Lz is equal to E. So 4A upon 2A square, therefore this is equal to 2 times rho upon E. So R1 is equal to 2 times specifications. So this is the equation 1. So resistance along x-axis by the wire is equal to this much. Second, R2 is equal to resistance along the path CD. Therefore, R2 is equal to RCD is equal to RYY is equal to rho into Ly upon E. So this is equal to rho into Ly. Ly, the length along the y-axis is equal to 2 times E upon. Now area of cross section along this axis is equal to 4 times E multiplied by E. How about the area level? 4 times A multiplied by E. So this is equal to rho upon 2 times E. So R2 is equal to rho upon 2 times E. This is equation 6. Now the third relation is the R3. Case number 3. R3 is equal to resistance along the path EF. So R3 is equal to REF is equal to RZZ is equal to rho into Lz upon E. So rho into Lz is equal to E upon area. Now along Z axis, this is the area of cross section. So this is equal to 4A multiplied by 2A. So this is equal to rho upon 8 times E. So R3 is equal to rho upon 8 times E. This is equation 3. So R1 H2 R2 H2 R3 is equal to R1 is equal to rho upon 2A 2 rho upon E rho upon 2A rho upon 8A. So take the LCM 8. So this is equal to 16 times rho upon E H2 8 multiplied by 2. We are multiplying 8 multiplied by 2, 8 multiplied by 2 upon 2a, 8 into rho upon 8a. So this is equal to 16 times rho upon a, 4 times rho upon a, rho upon a. So this is equal to 16 as to 4 as to 1. हा रेशो आपल्याला विचारला पण असा पण प्रॉब्लेम विचारला जाऊ शकतो. अँड दॅट R1 is greater than R2 is greater than R3. This is the result. This type of answer can also be asked. And therefore correct choice is B. B choices. Correct. So logically also you can give the answer, because resistance is directly proportional to length. So this length 4 times A is highest. Therefore, this resistance along the path AB will be more. Now it is inversely proportional to the area of cross section. So this area of cross section is smallest. So along the path AB, length is highest and area of cross section is lowest, minimum. Therefore, resistance along the path AB, R1 will be highest. Logically you can give, but if we have to compare the ratio like this, then you have to calculate each and every resistance along the path AB, along the path CD, along the path EF, like this. And that's why I have calculated this value like this. It is again related with the basic formula of resistance of a conductor. The specific resistance of a wire is rho. Its volume is 3 meter cube and its resistance is 3 ohm. Then its length will be. So we have to find the value of length in terms of rho. So given quantity is like this. Rho is equal to specific resistance R resistance is equal to 3 ohm. Volume V is equal to 3 meter cube. Length L is equal to question mark. Length L is equal to question mark. So resistance of the wire R is equal to rho into L upon A. A is equal to area of cross section. Area of cross section. Therefore, R is equal to rho into L upon A multiplied by L divided by L. So this is equal to rho L square upon A into L, but A into L is equal to V is equal to volume of wire, and therefore R is equal to rho into L square upon V. आपल्या प्रॉब्लेमसाठी लागणारा फॉर्म्युला हा झाला. Therefore L square is equal to R into V upon rho. So R is equal to 3 ohm, volume is equal to 3 meter cube upon rho, and therefore this is equal to 9 by rho. And therefore taking square root, so L is equal to root 9 by rho, that is equal to 3 upon under root rho. So length L is equal to 3 upon square root of specific radius of. So correct choice is B. B is correct. Next, question number 36. A cell supplies a current I1 through a resistance R1 and current I2 through a resistance R2. The internal resistance of the cell is so here we are using two load resistances. One is R1, other is R2. So by Ohm's law, when this resistance changes, the current will also change. So in the first circuit, the resistance connected is R1. In the second circuit, the resistance connected is R2. The cell is remaining same, and therefore no change in EMF of the cell, no change in internal resistance of the cell, but R2 changes, therefore current will change. So this current is the I2. So these are two separate circuits. Figure 1, figure 2. So current I1 is equal to EMF E upon R1 plus R. On this side, current I2 is equal to E upon R2 plus R. And therefore, E is equal to I1 into R1 plus I1 into R. E is equal to I2 into R2 plus I2 into R. This is equation second, this is equation 1. So, in equation 1 and 2, E and R are same. In 1 and 2, EMF E and internal resistance small r are same because same cell is used. Therefore, equating 1 and 2. Equating 1 and 2. So I1 R1 plus I1 small r is equal to I2 R2 plus I2 into small r. Therefore, I1 into small r. Now we will collect the term of internal resistance on left hand side. So I2 R2 minus I1 R1. So R is common into bracket I1 minus I2. I2 R2 minus I1 R1, and therefore internal resistance R internal resistance small r is equal to I2 R2 minus I1 R1 upon I1 minus I2. This is the correct question. Generally अशा टाइप of problem मध्ये न्यूमरेटर डिनोमिनेटर दोघांना मायनस मायनस साइन येतात. तर साइन वरून आपल्याला काय लॉजिकली ठरवता येऊ शकतं. So D choice is correct. D is correct. Like this. So by substituting value, we can calculate this resistance. 37. 2, 4 and 6 Siemens are the conductance of three conductors. When they are joining in parallel, their equivalent conductance will be. The conductance हा resistance reciprocal असतो. हा basic formula आपल्याला माहिती पाहिजे. So conductance is equal to 1 upon resistance. Symbolically, S is equal to 1 upon R. So, SP is equal to conductance of parallel arrangement. P for parallel. Parallel arrangement. SP is equal to S0. Therefore, SP is equal to 1 upon RP. RP is equal to resistance of parallel combination. Parallel combination. Therefore, SP is equal to 1 upon RP is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 is equal to S1 plus S2 plus S3. Another formula. So conductance in parallel arrangement is equal to S1 plus S2 plus S3, and these three values are given 2, 6, 4. Therefore, SP is equal to 2 plus 4 plus 6 Siemens. So that is equal to 12 Siemens. So correct choice is A. A choice is correct. So this is a new relation about the conductance of a wire. Conductance and reciprocal. Conductance is the reciprocal of resistance, and resistance has parallel equation 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, etc. Next question, 38. N identical cell, each of EMP and internal resistance small r are connected in series. A cell A is joined with reverse polarity. The potential difference across each cell except A is the potential difference मध्ये आपल्याला TPD करायचं आहे. So the arrangement is like this. N cells are connected in series. Suppose we are using the N cell like this. L is equal to number of cells joining series. E is equal to EMF of each cell. R is equal to internal resistance of each cell. When all N cells are connected with same polarity, then total EMF ET is equal to N times E. Total internal resistance RT is equal to N times R. This is equation 1. Case number 2. When one cell is connected with a reverse or opposite polarity, then ET decreases by 2 times E. Therefore, new value of total EMF E dash T is equal to N times E minus 2 times E, so that is equal to N minus 2 times E. Therefore, current I is equal to E dash T upon RT. So N minus 2 into E upon N times R. This is equation 1. So this is the net current flowing through the circuit. Now let V is equal to terminal terminal potential difference across any one cell except A. Therefore, V is equal to EMF E minus R into small r. EMF of each cell. So, this is equation 2. Put 1 into, therefore dPd of the cell is equal to E minus, now value of I is this, n minus 2 into E upon n into R into R. So RR will get cancelled. So this is equal to E minus n minus 2 into E upon n. So n into E minus n into E minus minus plus 2 times E upon n. So any will get cancelled. So this is equal to 2 times E upon n. So potential difference is equal to 2 times E by n. So this is the correct answer. So D choice is correct. D is correct. हा एक सेल आपण रिव्हर्स पोलॅरिटीने कनेक्ट केला म्हणजे ह्या दोन EMF कॅन्सल होऊन जातील म्हणजे टोटल EMF बी इथे 2 ने कमी होते. असे दोन सेल जर आपण ऑपोजिट पोलॅरिटीने कनेक्ट केले तर इथे 4 टाइम्स E आला. दिस प्रॉपर्टी इज इम्पॉर्टंट. व्हेन वन सेल is connected in reverse polarity, the ET decreases by 2. तर आपण दोन सेल ऑपोजिट पोलॅरिटी कनेक्ट केले असते तर 4E ने कमी झाले असते. सो दिस इज द व्हॅल्यू ऑफ द टर्मिनल पोटेन्शियल. So I will read the question. In a potentiometer experiment for measuring the EMF of the cell, the null point is at 480 cm when we have a 400 ohm in series with the cell and galvanometer. If the series resistance is reduced to half, the null point will be at. हा रेजिस्टन्स जो त्याची पोझिशन महत्वाची. So I will draw the circuit of potentiometer. This is the potentiometer wire. This is the driver cell of EMF. This is the plug key. This is the rheostat. This is called as a potentiometer. RH, K, EMF E, internal resistance R. So it will send the current I. That current will flow from first wire, second wire, third wire, fourth wire, rheostat, the key like this. So I is equal to EMF E upon R plus RH. R is equal to resistance of wire AB. This wire is AG. Now, the cell whose EMF is to be determined is connected here. So this is the EMF E1. This is the resistance R dash, and this is galvanometer resistance like this. So this balancing length is when radiation R dash is in series with measurement cell E1 and galvanometer. Then if D is a null point and L1 is a balancing length, then E1 is equal to I R dash L1. So this is the question now, where R dash is equal to R by L. L is equal to length of the wire AB. Length of the wire AB. When R dash becomes half, then no change in I and R dash in equation 1. Therefore, null point remains same because no current flows through cell E1, radiation R dash and galvanometer G. Therefore, null point is independent of value of R dash. And therefore, what is our question? If the series resistance is reduced to half, then the null point will be. So, null point D remains at same point at 480 centimeter. No change in the position of the null point. So correct answer is the C. C is correct. C is correct. हा रेजिस्टन्स चेंज केला आपण तर नक्कीच नल पॉईंट चेंज होईल. हा रेजिस्टन्स चेंज केला तर काहीच इफेक्ट होणार कारण ह्या ब्रँडमधला करंट होतो 0. But D is a null point. There is no flow of current in this branch. No current. करंट जर फ्लो नाही तर तिथे R dash आपण हाफ केला काय डबल केला काय त्याच्याने काही फरक पडणार नाही. सो दिस इज अबाउट क्वेश्चन नंबर 39. नाउ last question number 40, it is same as question number 20. So we have taken these two problems together. So here the paper is complete. Test number 57 related with the current electricity is complete. Okay. So we will stop here. Next time we will start new chapter